Imagine a world without numbers. Not just the symbols on a screen or a page, but the very concept of 2, or 10, or a million. How would you build a house, or trade goods, or even know how old you are? It's almost impossible to conceive of our reality without them. But this raises a profound question. Are numbers a fundamental feature of the universe that we simply found, like a new continent? Or are they a brilliant tool that we invented, a language created by the human mind to make sense of it all? This isn't just an abstract puzzle. It cuts to the heart of what reality is, and humanity's place within it. Does the universe have an underlying mathematical structure, or do we impose that structure upon it with our consciousness? To understand this, we need to explore two vastly different ways of looking at the world. One sees us as cosmic explorers, the other as cosmic architects. Let's start with the architects, and the idea that numbers are an invention. In this view, numbers are a product of human culture and cognition, a sophisticated system we designed to solve problems. Evidence for this begins deep in our evolutionary past. Imagine an early human ancestor. They don't need calculus, but they do need to know if all the members of their hunting party have returned, or if they have enough fruit for their family. The first step isn't abstract mathematics, it's simple one-to-one correspondence. One pebble for every person, one scratch on a bone for every bison seen. This is exactly what the archaeological record suggests. The Lubombo bone, found in Eswatini and dated to around 43,000 years ago, is a baboon fibula with 29 distinct notches. The Ishango bone, from about 20,000 years ago, has more complex groupings of tallies carved into it. These aren't numbers as we know them, but they are a form of data storage. They are a technology. Just as we invented a hammer to apply force to a specific point, we invented tally marks to solve the problem of memory and quantity. They don't exist out there in nature. They are tools created by a thinking mind. From there, the invention grew more complex. Over thousands of years, different cultures developed unique systems. The Babylonians used a base 60 system, which is why we still have 60 seconds in a minute and 360 degrees in a circle. The Romans used their iconic letters for numerals, a system that was clumsy for large calculations. Many species can perceive small quantities. A crow can know the difference between 2 and 3 nuts, but only humanity developed a symbolic language for it. Essentially, this argument frames mathematics as a language. We created nouns, numbers, verbs, operators like plus and minus, and grammar, rules like the order of operations. The statement 2 plus 2 equals 4 is true in the same way the sentence "a bachelor is an unmarried man" is true. It's true by definition, based on the rules of the system we created. The symbols and the rules are human inventions. If a different intelligent species evolved on another planet, their mathematics might be built on entirely different foundations, creating a system that would be unrecognizable to us, but just as effective for them. This idea feels especially strong when we consider more advanced mathematical concepts. Where in the natural, physical world would you go to discover a negative number, or the square root of -1, the so-called imaginary number? These concepts were not found by looking at rocks or stars. They were invented by mathematicians to solve problems that arose within the mathematical system itself. They are extensions of the game, new rules and pieces created to make the game more powerful and consistent. In short, from this perspective, the entire edifice of mathematics is a magnificent human construction, built by billions of minds over millennia. It's our most successful story, a shared fiction we all agree to use because it's so incredibly useful. But what if that's all wrong? What if we aren't the architects at all? What if we're more like explorers mapping a hidden landscape? This brings us to the second great idea, that numbers are a discovery. This view, often called Platonism, proposes that numbers and mathematical laws are real, abstract objects. They exist outside of space, time, and the human mind. They were here before humanity evolved, and they will be here long after we are gone. When we do mathematics, we are not inventing rules, we are uncovering timeless truths about the fundamental nature of existence. To understand this, think about the number 3. The inventionist says, 3 is just a symbol or a word. But the Platonist asks, what is the property that a triangle, a trio of birds, and a 3-leaf clover all share? They all share the property of threeness. This abstract quality of threeness is the real number 3. The symbol 3 and the word 3 are just labels we've assigned to it. like naming a star that was already there. We didn't invent threeness, we became aware of it. In this view, 2 plus 2 would equal 4, even if no life existed in the universe to notice it. It is an eternal fact. The strongest evidence for this perspective is what the physicist Eugene Wigner famously called the unreasonable effectiveness of mathematics in the natural sciences. Why should this abstract language we developed be so spectacularly good at describing the universe? Albert Einstein's equations for general relativity, born from abstract mathematical reasoning on paper, predicted the bending of starlight by gravity years before it was ever observed during a solar eclipse. Paul Dirac formulated an equation describing the behavior of electrons, and in doing so, found it also predicted the existence of a new particle, antimatter, which was later discovered. Time and time again, mathematical structures developed for purely abstract reasons turn out to be the perfect blueprint for some aspect of physical reality. It's as if the universe is whispering its secrets to us in the language of mathematics. This seems like too much of a coincidence to be an accident. It suggests that the universe itself has an inherent mathematical structure. We also see mathematical patterns emerging in nature, independent of the human mind. The Fibonacci sequence, where each number is the sum of the two preceding ones, appears in the arrangement of seeds in a sunflower head, the branching of trees, and the spiral of a nautilus shell. The constant pi, the ratio of a circle's circumference to its diameter, is the same for every single circle in the universe, from a raindrop to a galaxy. Are these just quirks of evolution and physics, or are they evidence that these numbers are woven into the fabric of reality? To the Platonist, they are clues left by the cosmos, demonstrating that we are living inside a mathematical structure that we are only just beginning to perceive. So we are left with a fascinating split. Are numbers a human-made tool, a language of our own design, or are they a fundamental truth of the universe, an objective reality we uncover? But what if the answer isn't a simple choice between one or the other? What if the truth lies somewhere in the interaction between the two? This third path suggests that mathematics is a unique collaboration between the universe and our own consciousness. This view, sometimes called constructivism or intuitionism, argues that numbers don't exist in some abstract Platonic realm, but they aren't arbitrary inventions either. Instead, they are constructions of the human mind, but constructions that are guided and constrained by the way we perceive reality. To understand this, we have to look at the basic faculties of the human mind. We seem to have an innate ability to distinguish one object from another. We can perceive a sequence of events in time, a before and an after. According to this view, the most basic mathematical idea, the sequence of natural numbers 1, 2, 3, and so on, is born from this fundamental experience of time and succession. We create the number 1, then we create the next one, 2, and the next one, 3, in a process that could go on forever. So, numbers aren't out there waiting to be found, but they aren't just a game with arbitrary rules either. They are the result of applying our most basic cognitive functions to the world. We are built to see patterns, to separate things, to order them. Mathematics, then, is the formal expression of these deep-seated intuitions. It's a system that grows out of the very structure of our consciousness as it interacts with the world. This explains why math feels both invented and discovered. The act of creating new concepts, like imaginary numbers, feels like an invention, but the fact that these concepts must be logically consistent with everything that came before makes them feel constrained and objective, as if we are discovering their necessary properties. It's like building with Legos. We choose what to build, but we are limited by the shapes of the bricks and the way they connect. Our consciousness chooses what to build, but the laws of logic and the structure of reality provide the bricks. In this light, the unreasonable effectiveness of math makes a different kind of sense. Of course, mathematics describes the universe well. It was built from the ground up using the same mental tools we use to perceive and make sense of that very universe. Our language for reality works because it's a product of our interaction with reality. So, what does this all mean? We are left with three compelling stories. One where we are master toolmakers, inventing a language to impose order on a silent cosmos. Another where we are cosmic detectives, discovering the clues to a pre-written mathematical reality. And a third, where the universe and human consciousness are locked in a creative partnership, co-authoring the story of existence. Ultimately, the question of whether numbers are invented or discovered may not have a single answer, because it may be the wrong question. The real mystery might not be about the nature of numbers, but about the nature of the mind that is able to conceive of them. In our long journey to understand the cosmos, we might find that the mathematical structures we use to explain everything out there are also the most profound reflection of everything in here. And in the end, our search for the universe's code might be a search for our own. If you enjoyed this exploration into the code of our reality, consider subscribing for more.